Good day, fellow. Setso is back. Today we are going to do the new concept, obviously, of electricity. Then let us define the term electricity. The term electricity implies flow of charges. This is just the simple definition of what? Of electricity. Now we know that the electricity is the flow of what? Of charges. Typically the negative charges, which is electrons, the flow of electrons somehow. Then now, since we know the definition of electricity, let us move to Ohm's law. Ohm's law, which is given by I, let me write it here, which is IR. Then it states the voltage across the conductor is directly proportional to the current, but inversely proportional to the resistance. Provided the temperature should be kept constant. We have three components here: resistance, current, as well as voltage. You see now, this is just the definition of what? Of Ohm's law. Then now we have different kind of conductors. Firstly, we have ohmic conductors as well as non-ohmic conductors. What are those? Ohmic conductors, they obey Ohm's law. Its function is like this. Let us consider this one to be V and this one to be I. Its function is like this, a straight line. Then we also have what? The non-ohmic. They don't obey Ohm's law. Then its function is like this. Right here we have V, then this side we have R. Then the gradient of this graph, it represents what? The resistor. The gradient, change in V divided by change in I. Bear in mind, the value of R is constant for ohmic conductors, but for non-ohmic it changes over time. It changes. But as for ohmic, it's always the same throughout. Then yeah, now we are going to consider components. Let us consider components. From our definition of Ohm's law, or let me just say the Ohm's law formula. Let me write it like this. Over R, we have current, the first component that I'm going to talk about. We have current. The symbol of current is I. Then its unit, it's ampere. Its unit, I'll put it inside the bracket, it's ampere. Then the definition of current is the rate, or let me just say the rate of flow of charges. The rate of flow of charges. The current is given in a form of Q, charge per unit of time. This is the formula of what? Of current. Then we also have what? The voltage. Its symbol is V. It's measured in volts. I'll just say V. Then its definition is amount of energy per unit charge. It's like this. We have V, which is equals to work, amount of energy per unit charge. Then lastly, we have what? The resistance. Resistors. Let me say resistance. Its symbol R. It's measured in ohm. Right? Its units ohm, V, then ampere, A. Then now the definition of resistance. It impedes, it resists somehow the flow. It impedes the flow of charges. You see, this is the definition of each and every component that we have. Then now I'm going to consider two cases, parallel as well as series connection. Suppose if I have a series connection like this, let's say, let me erase it. Let's say somehow if I have a series connection of two resistors. Say I have, let's say, 2 ohm together with 3 ohm. I have two resistors, this one and this one. Then I want to know as to how I will calculate these given resistors, especially in a series connection. It's so simple. For us to find R total, which is our resistor, we are going to add I1 together with I2, which is going to be 2 plus 3. Your final answer is going to be 5 ohm. You see? Bear in mind, we have 2 and 3, but when we add them together, we get 5. Then now let's check if our connection was in parallel. Then I'll write parallel connection. And now let's check. I'll take the same values, but now we connect them like this in parallel. Say this one is 2 ohm and this one is 3 ohm. And now let us calculate the total resistor in parallel connection. Then how are we going to calculate them? we use this formula R. Let me say series. Yeah, let's say R series. This one, let's say parallel. It's going to be 1/2 plus 1/3. Then okay, from here let us simplify. It's going to be this multiplied by this 6, you get 3 plus 2, your final answer. So far we are going to get 5/6. You can just use your calculator if you want to. Then now from here we haven't found our final answer at this point. Now let us take this one up, this one, we just swap them like this, you see. Then our final answer is going to be 6/5, then R parallel. This is our final answer. Let me take a calculator to see the value in a decimal. Is going to be 1.2. 1.2 what? Boom. Check. I hope you notice something. I hope you notice something between the two connections. As for the series connection, each we had 2, we had 3, but our final answer is greater than both of them. You realize something, that as for the series connection, each resistor, it increases more. But now if we connect our resistors to be in a parallel form, somehow we decrease what? The total resistance of what? Of the circuit. Do you see? Check. The total value is less than the 2 given what? Resistors. Then now we are going to consider another component. Now here we were talking about the resistance. Now let us do the concept of what? Of current. Suppose if somehow there I have an ampere. Let's say my current somewhere there is, let's say 2 ampere. Then as a learner, you just need to know, if I have a series connection, the current will be same throughout. That means current of 2 ohm will be equals to the current of 3 ohm, which will be equal to the total current, which is 2 ampere. See, we are going to get the same current for the resistor 2 as well as 3. But as for the parallel connection, we won't get the same answer. Then how are we going to calculate the current that is going to go to 2 ohm as well as 3 ohm? Check. We are going to use this method. Suppose we have the same again. Let's use the same value, 2 ampere. Then how are we going then to figure out 2 and 3? How are we going to figure out the current in each resistor? We have different methods. The method that I'm going to use now is this one. We know that current is inversely proportional to what? Somehow to the resistor. It's inversely proportional. Then I only have 2 resistors. Then check the current that will move to 2 ohm, it will be greater compared to the one that is going to flow to 3. Normally for this type of a question, you will just swap the resistance and say this side we are going to get the current of 3x. You just swap these two numbers and place x next to it. Then this side we are going to get 2x current. Then for us to calculate the current that is moving to this one and this one each, we are going to say now I have 2x in plus 3x, but our total must be 2, this 2. Then let us add the 2. If we add them together, we get 5 is equal to 2. Then we divide by 5, we divide by 5. Then we get x to be. Then from here, how are we going then to figure out the current in 2 ohm? So simple. You see next to x, just need to substitute this value. This value next to x, then the I of 2 ohm is going to be 3. Next to x, we substitute 2/5. Then this is going to be our final answer, which is, let me use calculator, 3 divided by 5. We get, let me check, it's 1.2, sorry. We get 1.2 watt ampere. Then for I, 3 is going to be 2. Next to, we substitute 2/5, which is going to be 2 divided by 2 divided by 5. Our final answer is 0.8 ampere. Then in total we should get 2 if we add, let's say somehow current continue to flow, same this one continue to flow, somewhere there we should get the same value of 2. Let us add them to see if we get the same. 1.2 plus 0.8, indeed we get 2. This is another method that we normally use to calculate what? To calculate the current in each resistor. But we also have another method, which is this one. Let me erase here. Firstly, we need to find the voltage of both resistors. Then firstly we are going to say, for us to find the voltage, we must have the total resistor, which is going to be, oops, I forgot from the previous one, but let us calculate it quickly. We use this formula 1 2, I said 1 3, then we said this multiplied by this. You can use your calculator. This 0.3 is 2, then I got 5/6. Do you still remember? But at this point we switch them, then our answer is going to be R parallel 6/5 watt ohm. Then now we have a situation which is like this. Now we have something like this now, which is 2A. At this point we have something like this, 6/5 watt ohm. We have something like this. We have found the value of both of them. Then let us calculate V. We know that V is given by IR. Then let us substitute, this is R parallel that we have found. Then it's going to be 2 multiply this 2 multiplied by 6/5. Then we get 2 multiply by 6 divided by 5. Our final answer is going to be 2.4 volts. You see, we get this value 2.4. Now at this point we know that each will have the same voltage, which is going to be 2.4. For us to find the current, we'll then just say I for 2 ohm is going to be V over R. Where we see our V, we substitute 2.4, which are 2 of 2. Then underneath we substitute 2. Our answer is going to be, hopefully I did not make any mistake, 2.4 divided by 2. We get 1.2 watt. 1.2 watt ampere. Do you still remember we got the same answer that side? Then we also do like this for us to find of this one, R of 3 going to be 2.4 divided by 3 now. Then which is going to be 2.4 divided by 3. We get 0.8 watt ampere. Sorry, just there, 0.8 ampere. Bear in mind, if I add 0.8 plus 1.2, 0.8 plus 1.2, we should get 2. Exactly, we get 2. You see, this is just another method. You can use it as well. Then okay, now we also have what? Voltage. I've already explained it, but now let me explain it again. Series as well as parallel. But now I'm going to consider what? Voltage. As for voltage, one thing that you need to know is let me remind you of the current. For the series connection, the current is the same. The current is the same. Don't forget that. For this one, we say it is a current divider. It divides what? The current. But now if we have a situation of voltage, a learner just need to know that if, let's say, I have something like this, let's say we have 1 here, somehow we have 2 here, our V is going to be the same. Somehow V of 1 ohm is going to be equals to V of 2 ohm, which is going to be same V. But now if I have this is a parallel connection. This is the parallel connection. Then here I have a series connection. Let me call it 1. Let me call this one 2. As for this one, this V together with this V, it must V1 ohm plus V of 2 ohm. It gives us what? V total. You see? Now things must change for voltage. we realize something, that for parallel connection, the voltage is the same. Voltage is the same for each watt resistor. Voltage is the same. But as for series connection, we have found that it's not the same. Instead, this one, it divides. Call it voltage divider. See, I hope you can see there. Okay, let me erase. Now we are going to consider, let's say I have a diagram like this, just for practice sake. Then we have our ampere, as well as maybe 1 here. Then I have 2 like this. Then I have something like this. Then I have, let's say, V1. Let's see here, it's 1 ohm, 2 ohm, we have 3 ohm. Somehow, let's say our voltage there, it's, let's say, 5 volt. Then I asked you this question: find current, let's say I1. How are you going to determine I1? For us to find I1 there, we have to find the total resistance of this circuit. Firstly, we will work out the parallel components, then we'll add it to this one. How? Like this. We are going to say 1 over R parallel is going to be 1 over R1, 1 over R2, which is going to be 1 over 2 plus over 3, which is equals to 6. You're going to get 6 over 5, which is your R parallel. And then for us to find R parallel, we switch them. See, switch them like this. Then we are going to get 6 over 5 watt ohm, which is RP. But this is not our final answer. At this point, we'll then add this number for us to find R total. We add the total of this to this one. It's going to be 1 plus 6 over 5. Now we add, because the connection is now in this format. We have 1, somewhere here we have 6 over 5 ohm. The connection is more like this now. Then let us add. We are going to say 1 plus 6 divided by 5, we get 2.2 watt ohm. Now we have our total resistor. Let us go to this formula. I Ohm's law, V. Our V is 5, I is 2.2. Then, so simple, you just substitute V5. Your resistance is, our resistance is, total is 2.2. Okay, 5 divided by 2.2, we get, let me round this answer to 2.7 ampere. See, this is our final answer for I. Then, can I ask you a question? Suppose if our circuit was not closed there, let's say we had an open switch like this at the beginning. Somehow, let's say if I were to give you it like this, then ask the value of I there if this circuit is open. Bear in mind, when the circuit is open like this, there will be no flow of what? Of charges. Somehow the value of I will be 0, nothing. You see, will be 0, because now there will be no circulation of electrons in this given what? In this given circuit. See? Then yeah. Then okay. Don't forget fellows, that at first we said an ohmic conductor, it obeys Ohm's law. It obeys Ohm's law, sorry. I say Ohm's law. Ohm's law. If I have a situation like this, somehow I have a situation like this. Let's say I have a situation like this. Then I give you maybe values, let's say from the start to the finish. Let's say it starts from 0. Let's say not from 0. Let's say somewhere here. Let's say somewhere here we have a value. Somewhere here. Let's say the value here is 2. Somewhere here, let's say the value is 5. And we allow this one to be, let's say 1. Let's say this one is 4. Then this side I have V, this side I have R. Then I ask you a question to determine the value of R. How are you going to determine the value of R? By taking the gradient of the given. That will be your answer. We'll then say, or we know somehow from mathematics that the gradient is given in a form of y over m. In this case, our gradient is our R, which is going to be change in V divided by change in I, which is, let's say, V final minus V initial, somehow this V, let's say F minus VI, same as I final minus VI. But now we take this V, substitute it here, minus 2 divided by 4 minus 1. Then you get 3 over 3, which is 1. See? 1 what? Ohm. I wanted to clarify the concept of the gradient. You see? Then now I continue.